So just like there's a video and a test for increasing, decreasing, there's also a test for concavity. And this video is going to be about explaining exactly what is concavity and why the second derivative test will find concavity on a function. So concavity is basically how much a function is changing. So functions can increase at an increasing rate or increase at a decreasing rate, and that's a fancy way of talking about concavity. You might have a function that looks like this. Concavity is basically, does the function have a bowl that points up or a bowl that points down? And right here in the middle, we'll call that a point of inflection. At the spot where this function's not concave up, and the function's not concave down either. It's just called a point of inflection. So right here in the middle, that's a point of inflection. That's what POI stands for. Okay, and right here, this is concave up, and this is concave down. And I always remembered it when I was in college because concave up looks like a cup. It would hold water. Concave down, well, it's the other one. So you got your concave up, you get your concave down. And both of those can be found with the second derivative test. And that's because the second derivative checks the rate at which the rate is changing. Remember, a first derivative is a rate. So a second derivative would be the rate that the rate is changing, which is concavity. So there's a number line test for that. You basically find where the second derivative, so the critical numbers for points of inflection are when the second derivative is 0, when the second derivative is undefined, just like the critical numbers for maxes or mins. So you'll make a list of these, put it on a Y double prime number line, and you'll put your critical numbers on there, and then you basically just check the sign in the middle. And when your sign is positive, you know the function is concave up when the second derivative is positive. And when the second derivative is negative, you know the function is concave down. And then maybe you change back to positive and know that the function is concave up again. So if this is what your y prime number line looked like, then your graph might look something like this. Concave up, then concave down, then concave up again. And right here are these two critical numbers. And since the critical number is in the middle of where your second derivative is changing signs, that tells you that both of these are points of inflection. So when the second derivative changes signs, you have a point of inflection. When the second derivative is positive, you have a concave up function. And when the second derivative is negative, you have a concave down function. And that's all about concavity. There's going to be examples following this in different videos.